Hello friends, today we are going to discuss the topic of features of microfacility. So the features of microfacility is basically three types: lexical expansion and parameter substitution, nested microcalls, and advanced microfacility. Under the lexical expansion and parameter substitution, there are the different types of the parameter, how that parameter is substituted into the particular expansion. Nested microcalls contain the different types of the micro within a one particular program. After that, the advanced micro facility contains the different types of the facility provided by the micro. So first one is the micro expansion. Micro expansion is nothing but it is related from the micro call. During the micro expansion, the micro call statement is replaced by the sequence of the assembly statement. So now the question is arise in our mind is what is the original statement and what are the different statements result after the micro expansion. So after micro expansion, the statement is expanded with a plus preceding. So there are the two types of the notation which is actually concerning to the micro expansion. First one is the expansion time control flow and second one is the lexical substitution. Expansion time control flow is dependent on the time. Time by time means it maintains the order of determining the model statement visited during the micro expansion. Where the lexical substitution in that it generates the assembly statement from the model statement. So first we look toward the expansion time control flow. So expansion time control flow is nothing but it is a default flow of control during the micro expansion and normally it is a sequential. So in the absence of the preprocessor statement, the model statement of the micro are visited sequential, starting with the statement with a micro prototype statement and ending with the MN statement. So now the preprocessor statement can alter the flow of the control during the expansion such that it will contain the conditional expansion and expansion time loops. Conditional statement is nothing but it is having some condition and it works on that particular condition. Whether the expansion time loop contains the repeatedly visiting during the expansion. So in this way we have to explain the expansion time control flow. Now the algorithm for the micro expansion specifies first the micro expansion control or the counter, which is the statement number of the first statement following the prototype statement. After that, the while statement pointed to the micro expansion counter is not the ML. If it is ML, then that time the program will be stopped there or there is no micro expansion present. So for that, the while statement is started from the MEC. After that, in that MEC, there is a if model statement which contain the expand the statement and increment the counter. In else part, the preprocessor statement will be executed. And the preprocessor statement is nothing but the micro expansion counter is equal to new value specified to the statement. And after that, the exit. In this way, the micro expansion will be worked. So second type is nothing but a lexical substitution. Under this lexical substitution, there are the three types of the statement. Strings are present into the model statement. First string, nothing but the ordinary, which stands for itself. Second one is nothing but the formal parameter with the character and. Third one is nothing but the preprocessor variable, which is also preceded by the character r. And so during the lexical expansion, strings of type 1 are written without the substitution. Strings of type 2 and 3 are replaced by the value. So string 1, that is nothing but the ordinary string, is useful for the substitution is retained without substitution, and 2 and 3 are replaced by the formal parameter. Sorry, value means formal parameter and preceded variables are replaced by the values. So in this way it is worked. So the formal parameter having the different types of the kind. like the positional parameter, keyword parameter, default specification of the parameter, micro with a mixed parameter, and other uses of my parameter. So first we will turn toward the positional parameter. So positional parameter, as name suggests, it shows the position, and it is replaces by and into bracket parameter name. For example, and sample, which shows the parameter position of that sample. Also, it will use the parameter kind. That type of syntax rule is omitted. This parameter kind is not specified. So in this way, we can find the actual parameter specification occupying the same ordinarily position in the list of the actual parameter in the micro call state. So in this way, the positional parameter are used. The example of positional parameter is shown into the figure, into the slide. Consider the call, that is nothing but the incr a comma b comma a register. In this particular statement, we can find out the position of the parameter. So the following rule of positional association: the value of the formal parameter are, first we have to define the formal parameter values by the memory value A, incr value B, register with the A register value. Lexical expansion of this model statement now leads to the position. So for the position, we just add the character, that is nothing but a plus before each statement. So plus move R to the A register comma A means we move that particular A into the A register, then add that B to the A register, and then move to the memory with the A register. The second type is nothing but the keyword parameter. Keyword parameter is also represented by the parameter name adjusting, and parameter kind is the string with the equal to in a syntax loop. So here we have to use equal to with the for the parameter kind. So which type of the kind, which kind of the parameter is used into that. So actual parameter specification is written as formal parameter name is equal to ordinary string. Then it is considered as an actual parameter. So the example for the keyword parameter is as shown to the slide. Please refer this example. The micro call is initialized first. From that micro call, we define the micro definition using the keyword parameter as shown in the slide. Third one is the default specification of the parameter. As a default specification of the parameter is nothing but the standard assumption in the absence of the explicit specification by the programmer. So default specification of a parameter is used in situation where the parameter has the same value in the most call. Means if one parameter having used under the different call, but it is replaced by the same value, then that time we use the default specification. And the syntax for specifying that formal parameter specification is as shown in the slide, and parameter name in square braces, parameter kind with the default value. The example of that is as shown into the slide. First, we have to redefine the micros with the default specification for the parameter register, and after that, we can first two calls are equivalent, but the third call is override with the default value. Hence, with the value of breg. In the next example, we have the different micro for the default value. Next one is a micro with the mixed parameter list. As the name suggests, the micro with the different kind of the parameter are encapsulated into the one micro, then that time it is called as a micro with the mixed parameter list. So in this, we have to mix up the positional as well as keyword parameter. So all positional parameter must precede all keyword parameter. For example, the micro call is sum UP A, B, G is equal to 20, H is equal to X. So AB, you all know A and B is showing the positional parameter, where the G and H are nothing but the keyword parameter. So correspondence between the actual and the formal parameter is established by applying the rules governing the positional and keyword parameters separately. So the other uses of the parameter that shown into the figure slide is nothing but the model statement have used formal parameter only in the absence field. However, that parameter is not restricted to that particular field. Hence, the formal parameter can also appear in the label and the upcode field of the model statement. For example, as shown into the diagram, after the example, also it is shown into the diagram. So, these were other uses of parameters are discussed. Next one is the nested facility of the parameter or nested micro facility. Under the as the name suggests, nested micro facility contains the one micro within the another micro. So for that, as shown into the example, there is a micro x with the parameter 1 and 2 having within that particular micro y is specified with the and parameter 2 where the register is equal to register 3. So in this way the nested micro is specified. So the nested micro expansion and call contain a model statement in a micro may constitute a call on another micro. So the inner micro or the micro containing the nested call is called as the outer micro. Thus, within that micro, the micro is present is called as the inner micro. And it will follow the LIFO rule. LIFO rule is nothing but the latest micro call is completed first. That is nothing but the inner micro is completed first. So the example of micro is as shown in the diagram and the expansion of that micro is expressed as shown in the slide. So first of all, micro X having the A and B with move R move to the register with the register 1 which stores the value of A. Then map micro with the Y is executed, it uses the register 2. So first of all, the operation under the register 2, that is add and move to the memory, is takes place first, and then the macro X is executed. So in this way, nested expansion takes place. After that, the next topic is the recursive micro. Recursive micro call is a situation where the micro expands itself. Means micro within that micro is expanding itself is called as a recursive micro. The micro definition does not contain any statement to stop any of their inner expansion and return to the complete the outer. This leads to the infinite loop. And a conditional statement is one mechanism to handle the recursive call. So the recursive call is shown to the figure where the micro is initialized as micro y with the parameter is equal to 1. Then the move that will contain the move register 1 and parameter, and again we have to call the macro y and with the parameter a. In this way the recursive call takes place. Advanced facilities, micro facilities are nothing but the facilities for the changing the microflow control. Then expansion time variable is also the advanced micro facility. Attributes of parameter, then the advanced directives are used under the advanced micro facility. That directives are nothing but the remove directive, relocation, that is IRP directive, and repeat directive. Advanced micro facility is useful for change the flow of control, and there are basically two purposes of advanced micro facility. First one is a expansion time sequencing symbol and expansion time statement. So in sequencing symbol is defined by putting it in the label field of the statement in a microblock. So the sequencing symbol is only used to define or by putting the label into that particular field of statement under the micro. Where the statement expansion time statements syntax are it uses the AIF command, AGO command, and KNOP command. So the syntax for all that is shown to the slide. So basically it is expression included relational expression. So it is using the relational or the condition statement for the true or false type of the statement where the sequencing symbols are also useful for the control is transferred to the sequencing symbol. So AIF is nothing but the expression. It is applied on the particular expression whenever that particular condition is only true. So that condition may be considered as a PT or the TR. Then that time the condition is true. And it will be also use the sequencing symbol for that. AGO is useful for the unconditional transfer, where the ANOP is useful for the defining the sequencing info. Example of that is nothing but the statement are generated only if the type attribute of both storage areas is the letter F, and the ADO instruction is useful for branches unconditionally. As shown into the slide, there is an example which shows the particular use of AIF and AGO. So please refer the slide. So here, if the condition is true, means y is equal to x, then the control will be transferred to the only dot only, that is nothing but the, which is representing the sequential sequence SS. So expansion time variable, under the expansion time variable, expansion values are the variables which can be only used during the expansion of the microcoil. There are the two different types of the expansion time variable, local expansion time variable and the global expansion time variable. Local expansion time variable are useful for the one particular micro, where the global expansion variable are globally used. So both are uses with the expansion variable specification. Means LCL, the syntax of that is nothing but LCL into bracket ED specification and GBL bracket ED specification. The value of ED can be changed using the set, is nothing but the preprocessor state. So expansion ED is shown into the diagram where the local parameters are used, or local variables are used, which is used to declare the variable A, as shown into the diagram. After that, attributes of parameter. Which are the different attributes are useful for the parameter? Normally, the syntax for representing the attribute is nothing but attribute name with a formal parameter specification, where the T is nothing but the type, L is nothing but the length, S is the size, and after using that we can define the mark. The example of a attribute defined by the parameter is shown in the diagram, where the parameter with a red mark, red color is useful for representing the parameter name. So x, n, and r, these are the three variables. Then the green color is useful for representing the expansion variable name, that is nothing but the m. Blue color is useful for presenting the sequence symbol name, that is nothing but the dot pp in the sequence symbol name, and pink color is useful for representing the actual parameter name. So the actual parameter is present into the microcall, that is nothing but the s comma 10 is nothing but the actual parameter with the value 10. So advanced directives. Which are the advanced directives are used in previous slide we will discuss the advanced parameter. The advanced parameter is nothing but the remove directive, which is useful for removing the micro from the micro definition table, and the IRP directive, which is nothing but the repeat directive, is used by the programmer to direct the assembler to repeatedly duplicate and assemble the sequence a number of the times determined by the compound parameter. Means under the compound parameter we can repeatedly use that particular directive. Is nothing but the IRP directive. So IRP directive is as shown into the diagram. So IRP P means P variable P parameter is repeatedly used into that particular. Next one is nothing but the advanced directive contain the microcode, that is the max x, which contain the different types of the value, and it will on execution it will represent the addition to the register A with the different types of the parameter A, B, and the hash 3. The repeat directives. The repeat directive is the another facility with the assembler to duplicate and assemble the sequence a number of the times during the micro expansion. So under this, the syntaxes are repeated into expression. Into that, we can repeat the values as per our need, and then on execution, the output will be produces. Please refer the slide for the example or the syntax of the repeat directive. So in this way, we have studied the different type of the facilities provided by Microsoft.